Deepak is the principal of ICF. It's a company that is very heavily involved in autonomous vehicle initiatives. They have a contract with Wyoming State. Deepak lives here in DC and works in Wyoming. They are actually doing a project for the state of Wyoming. Deepak has degrees in computer sciences, and he's been around for about 18 years in this business. Very knowledgeable. He has written many. He has publications to his credit. With that said, please welcome Deepak Gopalakrishna.
Thank you. Oh, I have my mic, yeah. Thank you. Just one correction. I'm a civil engineer, not a computer science person. So.
Sorry.
So hopefully it's a friendly crowd of civil engineers here. Thank you again for this opportunity to speak. I know it's a technical presentation, but what I'm hoping to do today is to make a case that connectivity is possible today, and more importantly, it's essential today to solve the problem that public sectors are having. So we'll talk about a project that I'm currently working on with Wyoming DOT. It's funded by the USDOT. It's part of the CV Connected Vehicle Pilot Program. And we'll go through the reason and the rationale for why WYDOT's disinterested in moving forward with connectivity as we wait for the AV future to emerge. So before I start off on the technical presentation, I just wanted to acknowledge the leadership behind this project. The lead for this is Wyoming DOT. Vince Garcia and Ali Reagan are sort of the project champions within Wyoming DOT, also the funding things. USDOT funds this project as part of the Connected Vehicle Pilot Program. We are one of the 3 locations selected. The others are New York City and Tampa Tia Hillsborough Authority. And the idea is to test the value of connectivity, especially DSRC connectivity, to enable safety and mobility applications that are possible today. We do have a large pilot team. We have an engineering firm in Wyoming. We have a few academics and researchers that are looking at the performance benefits associated with this technology. And then we have vendors, including Lear, SiriusXM, and some environmental sensing by a company called Fathom. And finally, as we go through the presentation, it's important for the state of Wyoming to recognize that this is not possible by themselves. One of the things about connected vehicles and automated vehicles is the need to get partners that you might not sort of generally involved with. So we are, they certainly work with Wyoming Trucking Association, but as part of this project, the engagement with fleet partners to actually work with fleet partner vehicles and install equipment on them, it's been a new and challenging experience, and we'll talk about some of that, some of those challenges. But the first few slides just are going to talk about the challenge we face, why connectivity and connected vehicles are an important project for Wyoming DOT. This is the problem. These are pictures from the last few years on I-80. How many of you have driven on I-80 in Wyoming? All right, those of you who've driven on I-80 in Wyoming know exactly how it is. For the rest of you, hopefully these videos serve as illustrative things. I'm from the East Coast. I wasn't prepared for the number of times an interstate can be shut down when you go to Wyoming, and we'll talk about that. They just shut that interstate down almost every day in winter there. So it's a heavy freight corridor. In certain seasons, about 50% of the traffic is trucks. More than, and over the year, it's about half the annual traffic. Lots of other traffic there in Wyoming. Severe winter weather conditions. The elevation is about 6,000 feet across the entire 402 miles, about 7,000 feet for at least 100 and something, and it peaks at about 8,000 feet in Wyoming at the summit. So, for those states that have mountain passes, this is driving on one long 402-mile mountain pass. So that's the plateau. There's no trees, no wind, no trees to block the wind, so you get tons of wind and visibility. So what happens? There are higher than normal accident rates, multi-vehicle crashes, and fatalities. This is happening today. So there's no waiting for an automated future to prevent this. We have to do something about this today. This is the winter that we had the baseline collection on, the last winter. I think it is the winter of 2016. 1,600 crashes on one. This is, again, remember, all these statistics are for I-80, 402 miles at the bottom of Wyoming. About 2,000 vehicles involved in these crashes. And when we added up the count of the closures, the time lost, the fatalities, the accidents, it was about $860-something million in societal costs due to sort of one road, fatalities, injuries, and productivity of time lost on that road. In the winter of 2016, there was about 250 hours of lane closures, about 180 hours of vehicle restrictions, and 37 days of inclement weather. So guess what? If you are a trucker in Salt Lake, the first thing you're checking is if I-80 in Wyoming is open. And so the weather watching is the favorite spectator sport in Wyoming. And you'll see that in a second. The other aspect of this is it's not localized. It's not a little bottleneck issue. These are closures across the corridor. Pretty much all 402 miles of the corridor have had a closure in the October and May timeframe last winter. So in the winter that just passed by, every sort of 5-mile segment, there was at least 1 or 2 closures around the entire 402 miles. So it's a corridor level problem. So when we wrote the CVP proposal, this was the most unfortunate way to sort of get an award for this. As this proposal in April, we sent the proposal in March. In April, this is what happened. And there's a lot of sort of important sort of findings here. I'll let you just watch it for a few minutes. Video with their mobile phone chatting in the media. It's also been a good recruitment tool because you'll see brands of trucks, FedEx, UPS. You call them right after and say, show them the video. This is what happens to the trucks in Wyoming.
Slow down. Jeez.
So this was vehicles coming down a slight slope on I-80. Just before this was a variable speed limit zone, so the speeds were actually slowed down. There was no fatalities, and I think it was a total of about 60 to 65 vehicles involved in this pileup. About 2 weeks later, there was another 60 to 65 vehicle pileup in a non-speed limit zone that resulted in a fatality. This happened right as we were beginning the project, and a couple of important messages that led to connectivity. One, when this first accident happens, the TMC has very little ability to communicate to that next 60, 70 vehicles that are approaching this really quickly. You need almost sort of a non-local response. You can't wait for the information to be communicated back to the TMC and then be broadcast back to the thing. You need some way locally to stop vehicles from running into each other. Second, where this happened, if you wanted, this obviously resulted in road closures for hours. So if you wanted to tell people to not enter I-80, you had to provide messaging about 50, 60, 70 miles behind. Because once you cross certain things, there's nowhere for you to go, no services, no truck parking. So these are the two big issues that came up. One is you need an ability, when an incident happens, to communicate very locally, very quickly, and then to be able to transfer that message maybe very far from the incident site. So these were the two big things. And just one more video just on the wind issue, because this is a real challenge that we face, this blowover risk. Again, for those of you who haven't driven in Wyoming, this might seem as again, the patrol car officer was safe. He was actually responding, but you'll see a truck approach by. This truck was not following the light vehicle restrictions that was in the on the on the road at this point. You'll see the truck come across. Yep, so that's blowover risk. One of the biggest reasons for crashes is single vehicle truck blowovers. And I think for those of you, I guess Pennsylvania has had some pretty large pileups as well. So these are problems that you face today that need solving. The other aspect to a corridor, like the Pennsylvania Turnpike or I-80, are the national impacts. So one of the things WYDOT certainly knows, and the term that they use is they can shut down Christmas for East Coast by closing I-80. Because a lot of the truck travel moves from west to east and east to west. So this is the origins and destinations of westbound freight on I-80. So if that doesn't make the case, here's the people that are subscribing currently to a commercial vehicle travel information portal. So WYDOT has a travel information website for freight truckers. I think the only state that's not subscribed, Maryland. Everybody else is interested. There are freight dispatchers that are interested in what's happening on I-80. And this is one of the important messages. The information that you have, that WYDOT has, and that you need to share, there is an audience for this that is far beyond those people who live in that I-80 corridor. So we started this project September 2015. We had about 150 subscribers to this commercial vehicle operators portal. Right now, there are about 1,500 firms that are subscribing to this information. An app, WYDOT released an app for 511 which showed road conditions in, I think, February of 2016. I think right now the number is closer to like 135,000 downloads of this app. As I said, weather watching is the most important thing you do. If you go to hotels, you'll have I-80 weather conditions. And so the need for actionable information is really, really critical there. So moving to the technical part. I'll try to not make this systems engineering driven and not systems architecture and all that, but I'll be happy to talk to anybody who wants more technical details. But this is what they wanted us. They wanted some way of forward collision warning just to prevent those kind of accidents. If I know that there's a truck stopped or a slow moving vehicle, I need to be warned. And there are a couple of others, the primary one being situational awareness. I want to know what's happening in the next 50, 100 miles of the roadway. And then from a DOT standpoint, they want to get better situational awareness of what's happening on their roadways, process that information, and share that back in a consumable manner. So these were the issues that the stakeholders were looking at. So what can we do today? We could wait for platooning. We could wait for automated trucks. Again, trucks are the problem. A lot of the discussions around automated vehicles are around light-duty vehicles. So what can we do? And I think there is a lot we can do with sort of connectivity in terms of better informing trucks at the right point so they can make better decisions. It certainly doesn't preclude future levels of automation, but there's certainly value in the C in CAV. For those of you who might not be very familiar with the terminology, here in our context, connected vehicles are vehicles that are equipped with some sort of device that enables communication to other vehicles or infrastructure. I think that's an important sort of message definition. So you could communicate to other vehicles that are similarly equipped with this technology or to the infrastructure. There are two terms that are frequently used: vehicle to vehicle, which is the communication that's from one vehicle to another, and vehicle to infrastructure, that is to the roadside units that are installed on the side of the roadway. And the idea is, by using this connectivity, you can first gather information on what's happening on the roadway, and second, you can communicate information and alerts back to the vehicles directly. So the Wyoming DOT pilot is part of the USDOT's Connected Vehicle Deployment Program. This was a funding opportunity that the USDOT had. 3 sites were selected to test this. Now, it is important to recognize that these the CV technology has been tried and tested. There's been several pilots and research studies, but it's still not a mature industry in a sense that you can't go and order connected vehicle technology like you would a DMS or a camera sign. There is still development. There is still research that needs to be done. So the idea of the pilot deployment was to spur some early adopters and then to test the results and really make a business case for other agencies to try it. So there's a lot of emphasis that we have in collecting the data, in measuring the performance, including the safety and the mobility benefits. And also coming up with a whole host of institutional documents on how we actually did this, what are the lessons learned, what did the DOT have to do to mainstream this. With that said, this is not a research project. The USDOT funded this project to say this is a deployment project, so you are expected to continue operations after our funding is done. So we are keeping this moving forward. We've talked about the 3 pilot sites. The New York City is focused, their scale is significantly larger than Wyoming. They have close to about 8,000 vehicles in like Midtown Manhattan. So a completely different environment than I-80 in Wyoming. They have entirely different challenges with respect to density of coverage, the GPS accuracy, the urban canyon issue, and we have different issues as well. But the idea was to test them in different settings. And Tampa is to look at a particular freeway section entering downtown, which is a tollway facility, and how you sort of use connected vehicle technologies and applications to prevent some of the problems that they're facing. So what is our pilot doing, and what sort of applications are we supporting? The first, just a couple of quick thoughts, and we'll go into the applications in a little bit. The pilot looks at connectivity, and at this point we are looking at DSRC connectivity. With that said, we have Sirius XM, so there's satellite connectivity as well. But the notion was to test sort of V2V and V2I DSRC connectivity in support of this application. As the corridor demands, it is focused on freight. We have 50% of the traffic's freight, so we are installing our equipment on fleet partners' vehicles. So commercial truck operations, we're getting them to agree that they will install and run and operate the systems. It's been much more challenging than you would imagine to get them to come do that. It's integrated with the Transportation Management Center. So it's not this research silo that is sitting there. It is actually part and parcel of day-to-day operations of the WYDOT Transportation Management Center. The systems that have been built feed directly into the Transportation Management Center, are seamlessly integrated. So from a TMC operator standpoint, they put in an alert and advisory. Backend systems translate that to the CV world language of J2735 and TIMS and BSM, whatever it is. They get translated backend. So from an operator standpoint, from a TMC management standpoint, it's almost independent what they're doing. WYDOT Fleets, one of the early starting points for a lot of connectivity might be the fleets that an agency owns. So the snowplows, the maintenance trucks, the buses, they are the starting point for connectivity. And one of the important reasons for connecting WYDOT fleets is you can collect data from them. So we have environmental sensors on these fleet vehicles, so they're actually collecting data about road condition, about visibility, about precipitation, and sending that back to the TMC. So we have greatly expanded coverage on I-80, so you no longer just need road weather stations. You're using these vehicles as probes for environmental sensing as well. We're going to have about 400 vehicles in the pilot. We have about 75 RSUs across I-80. If you do the math, 75, 402 miles, it's about 20 to 35 miles in between. But we have satellite connectivity on all of our units, so any vehicle traveling on I-80 can be geofenced and receive a message along any section of I-80. We have several trucking companies. That list is changing, and to be candid, people want to jump in, they recognize the complexity, sometimes they back up. We've had some other agencies, some truck companies come in. So that list is constantly changing, and one of the big things that we are doing right now is to get those memorandums of understanding signed, because there is quite a bit of a lift on top of a fleet partner. The equipment is on their trucks. It's their drivers that need to be trained on how to use it. And they need to sort of be responsible for maintenance and working with WYDOT on that. So there is a little bit of a engagement on their part that we are negotiating. But we've actually gotten really good feedback from a lot of small trucking companies in Wyoming that need this information. We've talked about this. The other aspect to connected vehicles is it not only benefits the vehicles that are connected, but the information collected through the snow fleets is actually being used to change variable speed limits on I-80. It's used to provide travel information on things like 511. So the idea is if you get better information in, it not only benefits the few connected vehicles, it benefits all travelers. So the same information that's collected goes back to the connected vehicles, but it goes back to everybody that's driving on this road as well. Again, we've talked a little bit about that, but each of the snowplows that we are having will be equipped with sort of environmental probe data. So there's this little, it's called SkyPack and RoadPack, little dongles that you connect that provide information about humidity and precipitation and weather that feeds into some TMC decision support systems that say, well, that looks like that road's icing or there might be a blowover risk there. Let me talk about the applications because so this is our onboard unit. It's a little box about this big that goes into the truck. It broadcasts messages on this DSRC communication method. It stores and transmits some event logs. These are what we use for performance measurement. Technically, if you're a Cadillac or a Toyota, you're not going to share us those event logs, but we need some way in the pilot to show that this is beneficial. So we have this method where we take a very anonymized sort of little log of what happened in interaction with another vehicle and process that and send it back. There's obviously a lot of antenna and wiring and how it needs to be set up on the vehicle. This is what a user sees. We can use their own tablet. A lot of these companies have their own onboard tablet or they have their own phone. But the idea is you would get warnings, you would get critical warnings, you would get forward collision alerts, you would get advisory warnings at the right point based on the applications that the pilot supports. 5 onboard applications. Forward collision warning. Again, the problem with forward collision warning is it's a critical mass thing. It's, again, remember, it's based on V2V. It's not based on sort of a vehicle having a radar to sort of do. It's really based on V2V communication. And the idea really is if you have a slow-moving snowplow that might have sort of a wing plow that really creates an envelope that's bigger than what you think and it's moving really slow, it is able to broadcast a message to a truck saying, hey, I'm moving really slow. You're approaching me. Just be warned. The next one is called distress notification. This might require just a little bit, and others are fairly straightforward. This was directly in response to the crash we saw. Let's say a truck over here is in distress, and it's one of our connected vehicles or it's in a group of connected vehicles. It is able to broadcast a message that is received by a vehicle going in the opposite direction that then becomes sort of a beacon, so it lets other vehicles know that there is a distress vehicle in the direction of your travel. The idea was to prevent that 60-car pileup from maybe getting to like about 20 or 30 cars. So the idea of using the opposite vehicle as a beacon was something that was suggested by truck drivers in our stakeholder meeting. Hey, is there any way that a vehicle approaching the other side could tell us there's something up ahead? So think of it as like flashing lights, but the modern application for on that. We've talked about this. Again, we do a lot of things with TMC operations. In the back office, connected vehicle data is used in day-to-day management. Highly private. There's hardware security modules all over. It's integrated. It's connected to sort of credentialing and certificate management systems. And honestly, this is what's been technically, it's the whole industry is evolving, and it's what's taken us a lot of time. But I think we're getting to a solution where every aspect of the linkage is gone through its security exercise in terms of how it needs to be protected and managed. So there's hardware security modules inside the vehicles, hardware security modules on the roadside units. There's sort of you protect the data in transit, and there's sort of certificates that say that, hey, this message is from a trusted source. The security by design architecture has been sort of the biggest challenge that we've faced, but I think it's been one of the most meaningful exercises we have. And it's very important when we show the slide that it kind of minimizes the concern that fleet partners have in terms of how the data is moving, how the bits and bytes are moving and secured as part of the pilot. One of the things we also are improving, and this is sort of a side project, but it's useful, is we have come up with a crowdsourcing application on the 511 app that's there to collect truck parking information. We thought about instrumenting parking lots around I-80, but part of the thing we said was, well, it's going to take a lot of money. We don't have that much money. Can we just use crowdsourcing from truckers who are using this 511 app to get information about truck parking availability? And we're starting to see some pretty good responses to parking lot information from truckers who are on I-80. So that's the, I don't know how much time I've used up, but current status. I think we are very close to phase 3. The development phase is done. The system is being tested. It's now, I think the end of September is witness testing. What I mean by that is USDOT is going to come and make sure we run some key tests so they can verify and we can accept the system. Once the system is accepted, we have an installation plan that we would go out to all the snowplows first, all the friendly fleets that we have, and then all the fleet partners. So over the next sort of few months, we're going to get a critical mass of vehicles that are moving around in the network. And at this point, the infrastructure is mostly built out. I didn't show, we have close to about 60 or so roadside units already built and active and connected in our pilot. We have about 18 months that we have to do a demonstration where we are running and operating this pilot and collecting data and reporting back on performance. We did an operational readiness demo, so just in case you're looking at how to do this in Pennsylvania, I think it's important to get a test track where you actually have real-world testing of these devices. There's a lot of issues with antenna placement, device shadows, and application stability that you would really need to test in a road environment. And so we have a test track off I-80 that we've set up various zones, and it also is a great place to demo stuff. So we've had legislatures, we've had WYDOT executive staff, we've taken them through the loop, and they've seen these applications in action. And frankly, it's been one of the most useful things we can do to build support for this, because there's a lot of terminology confusion about this. And when we started, there was a lot of issues with respect to, is this platooning, is this automation? But as we go through this and we describe sort of things like line of sight and what this does versus automation, I think having this test track and this demo site has been a huge, valuable asset for us. So we've already tested all the end-to-end functionality of all these applications. They all work. I don't think the applications are an issue at this point. It's not perfectly stable. You still need, if you bring it to Pennsylvania, you would still need to tweak it and develop it and tune it. But I think there are plenty of very smart people here who can get this working fairly quickly. We've done some training modules. We've built training videos for drivers, TMC operators. There's a huge training plan, because that's one of the biggest things, because there's a lot of subtle messaging that needs to be done. For example, if you're a connected vehicle driver today in our pilot, you need to be told that you might not get an alert every time there's an incident, because not all vehicles have this technology. You're certainly not a pilot, you're not in Waze, it's not like Waze. There's a lot of differences that need to be explained. So we spent a lot of time in building this training module. And outreach, we spend a lot of times, like this meeting, but others talking about this project, and it's been, again, a very useful exercise. Last slide, and I'll be happy to take questions. For more information, we have a pilot website. Our capability showcase, which is the capstone of phase 2, is coming up on October 30th and 31st. It's in Cheyenne, Wyoming. It's about a 2-hour drive from Denver. It's on I-25. Not anywhere close to as dangerous as I-80, but still, you can get a good flavor of wind, hail, and snow along that section if you come across. It's an open event. If anybody is interested in attending the capability showcase, please let me know, and we'll be happy to connect you and provide sort of invitations. For all technical documents, one of the things USDOT has been very good at in terms of this project has been to make documentation as it gets created available. So for the Wyoming pilot, you have all the system design, system architecture, testing plans, test documents. All of these are on a daily basis getting posted on our website. So if you have any questions on, hey, what was the test plan process like? What was the system architecture? What is the system design? What parameters did you use? How did you configure your RSUs? All of those technical details are available if you go to the pilot site at the USDOT pilot or CV pilots. So again, any questions, comments, I'll be happy to answer them. So with that, I think that's my last slide. All right.
Any questions? Okay.
Just a very basic question. I hear V2I, but I hear more frequently V2X. I assume it's the same thing.
V2X is V2 everything. So that includes cell phones, that includes cellular communications to back office. It includes things to pedestrians and cyclings. V2I is a particular subset of that, just to the roadside infrastructure.
Okay.
So.
Thank you.
In one of your slides, you showed that you're using DSRC as well as satellite for communication for a variety of different pieces. Was there a reason not to use cellular or some other wireless type of communications?
A good question. So dedicated short-range radio communication, DSRC, 5.9 gigahertz, is this very safety. It's meant for safety-critical applications. So it's really fast. It's really safe. It meets the needs and the requirements of safety-critical applications like forward collision warning and things like that. Our pilot was focused on that. There are technologies emerging like 5G that promise to do that, but they're not commercially. We couldn't buy a 5G system that's right now ready. In terms of some of the backhaul, we did consider cellular. So from this RSUs, for example, back to the TMC, we thought, but there's a cost associated with that. So we were hesitant to that. In some cases, that might still be the case. Satellite was useful because it's just broad-based. Again, there's no cost at this point. It's integrated with our onboard unit already. If it were cellular, there would be some cost associated with WYDOT that they didn't want to deal with it right now. But I think in their mind, they're pretty agnostic towards the communication method as long as the requirements for applications are met.
You had mentioned the truck parking application that was now being deployed on mobile devices. How much is WYDOT owning that and keeping that in-house versus allowing other developers in the Android or iOS ecosystem to sort of go out there and maybe make that a commercial entity?
So the truck parking is just we've built it into the 511. However, as part of this project, we did create a TMDD data feed, so a traffic management data dictionary, a standards-based data feed that is available to developers. So that includes not only parking, it includes events, construction, weather, advisories. So everything that WYDOT owns and puts out to the Travel Information Service is made available through a data feed or an API to other developers. And we are sort of actually working with a few developers who want to take it and use it to integrate it with their systems. But the parking itself is, we just built it into the 511 app right now. Yeah.
The future of DSRC versus 5G, are you seeing that's going to be equal longevity, or do you see DSRC version of 5G when 5G becomes?
This is beyond my pay grade per se, but my opinion is you will end up with a hybrid of these technologies, and it's quite likely that there will be regimes where DSRC works and regimes where 5G works better. But it's quite likely that you would end up. I think the important point for WYDOT is they don't see themselves in the onboard unit business, right? For them, it's infrastructure. And the primary goal for them is to figure out what is the best way to provide connectivity from their infrastructure. So depending on whichever technology that's taking over the marketplace, they would adapt to that.
I agree. I see it both ways. The short-range communications will always be there because of the
Yep.
And the broadcast capability in short-range.
Yep.
5G will be the backbone.
That's probably what's going to happen. But again, it's actively being debated by a lot of people. Different companies have different perspectives on this. But again, from a state perspective, they've been, I wish they were here to talk about, they've been kind of almost staying back on that fight, so to speak. I think they've been supportive of the need for DSRC or supportive for the need for V2V safety-based communication. I think that's the key. You want that. Let's not get into the spectrum wars quite yet. So.